The previous experiment measuring frequency using just a basic program had pretty decent results up until about 14 hertz, and then the error began to increase significantly after that. So, in order to get around this, for the Commodore 64 to count fast enough, I have to leave at least in part the basic program behind and go to a 6510 machine code, which is a processor the C64 uses. It's very similar to the famous 6502 processor. This is the concept of the setup for this experiment. You have the square wave generator over on the right. That's a 555 timer. We can change the frequency by changing the resistors in the 555 timer circuit. That makes a square wave. The square wave goes into bit 0 on user port B in the back of the Commodore 64. This booklet is where I got the circuit to make a square wave generator using the 555 timer. I thought I would include it here. The book itself now is kind of retro, and it is online. I'll try to put a link to it in the description below. This is the machine code or assembly language program that I wrote. Essentially what it does is it counts one count, every time the user port transitions from a 0 to a 1, it counts, and it will count up to 255 times. And after it's counted up to 255 times, it then returns back to basic. So it's not particularly sophisticated. I'm still learning machine code, and I likely will be learning machine code for a long time. And this here shows the concept of how the machine code was used. It was used inside a basic program. What this program does is it records the time as T1, runs the machine code, which counts 255 cycles, and then comes back from machine code, goes back to basic, records time again, and the frequency is obtained by dividing 255 by delta time. Again, this is not the best way to do this. There's obviously going to be limitations here. I expect that. But this is just sort of my first attempt to move beyond the 14 hertz you can get with BASIC into something higher frequency that might be more useful. Here's the simple program I came up with. It reads in the machine language, and then there's a simple basic routine after that where it measures the time, runs the machine code, comes back from that, takes the time again. That's the delta t. You divide that by 60 because it's in 60ths of a second. We know that we did counted to 255, so you divide that by your delta t, and that should be the frequency. Again, using basic like this to get the time is definitely going to introduce some errors and limitations on this. And here are the results. I ran some tests from about 30 hertz all the way to about 600 hertz. And in that case, the error on the C64 reading was between about 1.5% and 4% on the low side. And I expect the error is largely due, as I've stated before, due to using the basic timer. If there is a follow-on to this experiment, I think the next thing I'll do is try to find a more accurate way to measure the time